The paper explores the industrial practices of requirements engineering, RE, for machine learning, ML, enabled systems in Brazil. It highlights that 41% of Brazilian companies use ML to some extent, with several challenges reported when engineering ML-enabled systems, including unrealistic customer expectations and vagueness in ML problem specifications. The study aims to investigate the application of RE in developing ML-enabled systems in Brazil, focusing on current practices, perceptions, and problems in the Brazilian industry. The findings indicate distinct aspects of re-implementation in ML projects in Brazil, such as RE-related tasks being predominantly conducted by data scientists, the most common techniques for eliciting requirements being interviews and workshop meetings, a prevalence of interactive notebooks in requirements documentation, and practitioners reporting problems including a poor understanding of the problem to solve in the business domain, low customer engagement, and difficulties managing stakeholders' expectations. The study emphasizes that RE can help address several challenges when engineering ML-enabled systems, but establishing effective RE practices in ML projects may be difficult due to the lack of practitioners engaged in formal RE activities and the absence of tailored techniques and tools for data-driven projects. The paper concludes that the results provide an understanding of RE-related practices in the Brazilian ML industry, helping to guide research and initiatives toward improving the maturity of RE for ML-enabled systems. Additionally, the paper presents a survey design involving a literature review, expert feedback, and a pilot study to ensure the validity and reliability of the survey questions. The survey was distributed to professionals involved in building ML-enabled systems, and 276 responses were received, with 72 fully completed responses from professionals working in Brazil. The data analysis procedures involved using bootstrapping to calculate confidence intervals for the results. The results revealed that ML practitioners are extremely worried about requirements, with the problem understanding and requirements stage being perceived as the most relevant and complex lifecycle stage. The study population consisted of 72 practitioners involved in data-driven projects across various industries in Brazil, with diverse backgrounds and professional experience. The majority of participants were employed by companies with over 2,000 employees, and the most common roles represented were data scientists, business analysts, and project leads, project managers. Regarding ML-enabled system experience, most participants reported having 1 to 2 years of working experience, with a balanced population of beginner and experienced professionals. The educational background of participants showed that 87.5% held a bachelor's degree, 45.83% held a master's degree, and 19.44% completed PhD programs in computer science, data science, or related fields. The study's findings highlight the importance of addressing requirements in ML-enabled systems, with data scientists, project leaders, business analysts, and developers being most associated with requirements. The results provide valuable insights into the current practices, perceptions, and challenges related to requirements engineering for ML-enabled systems in Brazil. Here is a combined summary of the 4 pages. The study examines industrial practices of requirements engineering for machine learning, ML, enabled systems in Brazil, focusing on the problem understanding and requirement stage. Practitioners primarily employ interviews, workshops, prototyping, and scenarios to elicit requirements, with notebooks, user stories, and vision documents being the most frequently used documentation formats. Notably, data quality, model explainability, and model reliability are considered critical non-functional requirements. Managing customer expectations, aligning requirements with data, and resolving conflicts are the most challenging activities when defining requirements. The research utilized axial coding procedures to categorize emerging codes related to input, method, organization, and tools. Contrary to conventional expectations, data scientists are taking the lead in addressing requirements. However, practitioners face difficulties in understanding the problem, managing expectations, and dealing with limited customer or domain expert availability. Traditional requirements elicitation techniques remain widely used, with computational notebooks being the primary tool for documenting requirements. Nevertheless, a significant proportion of practitioners do not document requirements at all. The study acknowledges potential threats to validity, including biases and limitations in the sample population, but ensures rigorous data collection and analysis procedures. The findings emphasize the importance of effective communication and technical expertise in bridging the gap between aspirations and technological feasibility. The study's results highlight the need for practitioners to consider critical aspects of requirements engineering in ML-enabled system projects, such as managing customer expectations, aligning requirements with data, and resolving conflicts. Here is a combined summary of pages 910. In the realm of machine learning-enabled systems, requirements engineering practices deviate significantly from those employed in traditional systems, despite sharing common underlying challenges. A survey of 72 practitioners involved in ML system development in Brazil reveals discrepancies in perceptions, challenges, and practices. Managing customer expectations, addressing ambiguities in requirement specifications, and ensuring data quality emerge as key hurdles. The study underscores the importance of non-functional requirements, including data quality, model reliability, and explainability, which are often overlooked in traditional RE. Effective communication between project teams and customers, as well as stakeholder engagement, are crucial to mitigating these challenges. The findings suggest that while traditional RE challenges persist, ML-specific issues necessitate tailored solutions. The study contributes to the understanding of current practices and challenges in RE for ML-enabled systems, highlighting areas for future research and improvement.